Hello, dear students. Today we are going to have the last chapter to the second exam that will be after the spring break. Remember that the exam is in D2L, not in Cengage. You can make the Cengage exam as practice if you want. But the actual exam is in D2L in the same place as the quizzes. Remember that you will have the camera on all the time. Then, quantities in chemistry, we are going to see what is molar mass, the concept of mole, percent composition, and Avogadro's number. First of all, what is the molar mass? All the substances are made up of atoms or molecules. In chemistry, it is crucial to measure their quantities accurately. We use the international system, which unit is the mole. And to determine the number of reactants and products in a chemical reaction, we need the concept of mole. What is a mole? A mole is this big number that we call Avogadro's number. This number is bigger than the number of pieces of sand into the Sahara Desert. In order to give you an example, well, as 1 mole is assumed to contain 12 grams of carbon, 12 of the isotope 12. Then the number of Avogadro, or the constant, is equal to this big number that you can see here. That can represent what? It can represent atoms, molecules, ions, electrons, protons, anything. Also, we can say that can represent, for example, a number of planets, etc. It's the same concept of dozen. Dozen represents 12. 12 what? Well, it could be eggs, chairs, boys, girls, I don't know, anything. In this case, the Avogadro's number represents this big number of what? Of molecules, atoms, protons, whatever. Well, how we calculate the molar mass of a compound? In this case, we have CO2. We know that we have in CO2, we have 1 atom of carbon and 2 atoms of oxygen. Then we sum the mass of each atom in the compound, and the total mass is what we call molar mass. Here we have an example of how to calculate the molar mass of sodium chloride. I prefer to use the M capital to represent the molar mass. Then you have the mass of 1 atom of sodium and the mass of 1 atom of chlorine, and you get the molar mass of sodium chloride. Same way with sodium hydroxide. In this case, you have 1, 2, 3 atoms different. Stop the video and try to do it by yourself. Here you have another example. Stop the video. In this case, it's water that we have 2 atoms of hydrogen, then we multiply in this case, and 1 atom of oxygen. And then we add the products, and this is the molar mass of water. But how we can calculate the percentage of one element in a compound? Well, first of all, we have the molar mass of the compound that we calculated as we have done before. And then we use the total mass of one of the elements. And then we divide this by the molar mass of the compound, and we multiply by the mass of the compound that we consider 100%. And this is a way we can calculate the percent, for example, in this case, of A in a specific compound. For example, here you calculate the molar mass of CH2O. It is 30.0 grams. Then you want to know the percent of carbon in this compound. Then you divide 12, that is the atomic mass of one atom of carbon, divide by the atomic mass of the compound and multiply by 100, and you get the percentage of carbon. Same way for hydrogen and same way for oxygen. If you add the percentage of all the elements, you will see that is 100. Well, here I want you to calculate the percentage of oxygen in every one of these compounds. 1, 2, 3, 4, and 5. You can do it at home, and later you can send me the answer by mail if you want. You are not obliged to do that, but if you do, I will tell you if they are okay or not. The other thing that we are going to study today is to calculate the empirical formula. What is the empirical formula? For example, in a compound like this, A to B is the smallest relationship between the atoms of every compound, of every element in a compound, sorry. Then this is what we call the empirical formula, is the smallest relationship between the atoms in a compound. What we do? Well, step number one, we convert the percent of every element into grams. Later, if I told you that one compound has 40% of oxygen, you consider that this 40% represent 40 grams of oxygen in a compound that contains 100 grams. Then this is the first step. Step number two, you divide this mass that you got here by the atomic mass of the element in the periodic table. And you get what? Moles of the element. Later, what you do? You choose the smallest number of mole between the ones that you calculated in the compound. And you divide all the numbers or by the smallest ratio that you calculated. And this way you're going to get ratios. Okay, it's easy, you will see. Here we have a compound that contains 40% of carbon, 6.7% of hydrogen, and 53% of oxygen. First step, you consider that 40% is 40 grams, considering that the compound has 100 grams, then you consider that contains 40 grams of carbon, 6.7 of hydrogen, and 53.3% grams of oxygen. Later, what you do? You get these masses and you divide by the corresponding atomic mass. And you get what? Moles of each of the compound. If you see 3.33 and 3.33 are the same, at the same time is the smallest number of moles. then you choose this to divide all the other ones. In this way, when you divide every number of moles by the smallest, you get ratios. Then it means that your compound contains one carbon, two hydrogen, and two oxygen. So the empirical formula is CH2O. If this number is not a whole number, or for example, in this case, is very close to a whole number, like this, you have, in other case, you have to multiply by the same factor in such a way that all the numbers give you a whole number. You cannot accept, for example, 1.5. In this case, you better multiply by 2, and then you will get 3. Then, in this case, the smallest ratio is 1 atom of carbon, 2 atoms of hydrogen, and 1 atom of oxygen. So, this is the empirical formula. In this case, we are going to see this example. For example, this compound contains 69.6% of oxygen, 30.4% of nitrogen. You consider that these percentages are grams, and later you divide each gram by the atomic mass in the periodic table, and you get moles of every atom, and then you divide by the smallest. You say the smallest is 2.17, then you divide both by the smallest and you get ratios. In this case, you get whole numbers, and then you accept this whole number as the number of atoms in the empirical formula. I prefer you to write the nitrogen to the left because nitrogen is to the left of oxygen in the periodic table. Well, if you have the empirical formula mass, and for certain way you get the molar formula mass, how can you calculate the molecular formula? Well, you divide the molecular formula by the empirical formula, and you get N. And then you multiply N by every atom in the empirical formula. For example, if the empirical formula is A2O and N is 6, then the molecular formula will be the empirical formula multiplied by 6, then it will be A12O6. Let's do an example and it will be, sorry, easier for you. For example, the molecular formula is this, and the empirical formula mass is this. Then you divide the molecular formula mass by the empirical formula mass, and you get this number, that is N. What you do? Then you get the empirical formula and you multiply it by 6. Then the molecular formula will have this composition. Stop the video and try to listen to my explanation several times until you get the idea, and try to do it by yourself. Well, we have seen what is the Avogadro's number. How can we use the Avogadro's number in calculations? Well, you can go from number of particles to moles multiplying by the Avogadro's number. For example, if you have a 6 um, times 10 to the 10 atoms of, I don't know, uh, hydrogen or whatever, and then you divide by Avogadro's number. The Avogadro's number give you the, or you multiply, you can say that 1 mole is, and then down you put the Avogadro's number. That is the number that we studied before. So in this case, the Avogadro's number is also represents the number of atoms. Then you cancel up atoms with atom, and it will give you the number of moles of the compound that you can calculate from the number of particles. In the opposite way, if you multiply by the Avogadro's number, you will get the number of particles. For example, you say that you have 1 mole of a compound, and then you multiply by 6.02 times 10 to the 23 particles in 1 mole in such a way that you cancel out mole with mole and you get the number of particles that can be atoms, molecules, protons, anything. Then we can use the Avogadro's number to go from particles to number of particles to moles, or from moles to particles. Stop the video, take note, and try to do the following examples. For example, you have to convert moles to number of particles. How can you do that? Then you multiply moles by the Avogadro's number and it gives you number of particles. Here you have an example. Stop the video and try to do it by yourself. The opposite, you want to get moles from particles, in this case molecules, then you divide by the Avogadro's number and you get moles of the compound. In the other hand, you want to get moles from grams. How can you get the moles from grams? Well, you know that the mass is equal to the number of moles by the molar mass of a compound. Then, if you have the 2 moles of water, and you know that the molar mass of water is 18, you can say that the mass of these 2 moles is 36 grams. Is the way because you cancel moles with mole, then the answer will be in grams. Stop the video, try to understand this example, and let's go to the final one. In the opposite way, if you have the mass and you know the molar mass of the compound, you can get the number of moles. For example, you have 50 grams of carbon dioxide, and you know that the molar mass of carbon dioxide is 44 grams per mole, then you divide and you get the number of moles that you have in this mass of carbon dioxide. Well, as you can see, it's a little more complicated than everything that we have seen until this moment. But I promise that next chapter will be more difficult. Don't worry, you will understand everything. By now, try to stop the video and try to understand everything that I explained you. If you have any question, don't hesitate. Let me know and I will be with you as always. See you.